Good evening, my students of class 12. Today I am going to show you two different formats of integral calculus, and it's a very important format which you have to know it for your board examination as well as for your JE joints. So the form which we are written in the board can be derived through the system that is doing by integration by parts. So whenever we get this type of function, the trigonometric function can be considered as first function and this as second function. So we know that by doing integration of parts, the answer, let it be this be equals to I. So I equals to, the first function is this, so write down the first function cos bx plus c into integration of second function, that is e to the power of ax by a minus integral of, the differentiation of first function is minus sine bx plus c into b into differentiation into integral of second function, that is e to the power of ax by a dx. This is your second step. Now from this we can take it out, b by a outside. Finally what we get is cos bx plus c e to the power of ax by a, minus minus gets plus, bring down the ba outside, integration of sin bx plus c into e to the power of ax dx. Now considering this part to be I1, then what we get here, I equals to cos bx plus c into a to the power of ax by a plus b a I1. Now equation 1, now we have to solve out this I1. Okay, now we know that I1 is equals to this, again it will be integrating by parts. This is the first function and this is the second function. So from here we get is equals to sine of bx plus c, integration of this is a to the power of ax by a minus integration of differentiation of first function, that is this, that is cos bx plus c into b into differentiation into integration of the second function is e to the power of ax by a dx, which is equals to sine bx plus c e to the power of ax by a minus integration of, taking out b by a outside, we get cos bx plus c into e to the power of ax dx. Now see, this is considered, we have considered as I. Now putting the values in the equation, so we have got this, but we know that I is equals to cos bx plus c into e to the power of ax by a plus b by a I1, which we have got it earlier. Now this I1 means we have solved here, I1 is equals to this, instead of I1 we are going to put out this value. So finally b by a into I1 means we are putting this value over here, and then we get, from this we are getting I is equals to cos bx plus c e to the power of x, then b by a into this is b by a square e to the power of ax sin bx plus c plus minus minus b square by a square. Now taking this on the left hand side, we get I plus b square by a square I equals to, we are writing this itself, cos bx plus c e to the power of ax by a plus b by a square e to the power of ax sine bx plus c. Here simplifying, we get I as a common, a square plus b square by a square is equals to, from here if we take common a square, then we get a cos bx plus c e to the power of ax plus b e to the power of ax sine bx plus c. Now from here this gets cancelled off. We get here I equals to, taking e to the power of x as a common, this becomes here, it becomes division. Then we are writing here a cos bx plus c plus b sine bx plus c. So this is your final result. So I means integration of cos bx plus c into e to the power of ax dx is equals to this. So instead of this, if the quotient would have been given here, instead of cos it would have been sine bx plus c into e to the power of ax dx, then simple, the answer would have been same, but with respect to this could have been sine, this could have been minus, and this could have been cos. So your answer would have been e to the power of ax by a square plus b square, same as it is, into a, instead of cos it would have been sine bx plus c. Here it is plus, write it over here minus, then here it is b, write b here, write instead of sine, write here cos bx plus c. So in this way, with the help of this formula, we can remember this formula very easily. More two forms I am going to explain you today. The very first form is, instead of let a is equals to r cos theta, b is equals to r sin theta, then a square plus b square would have been r square. Therefore a square plus b square is equals to r square, or r is equals to root over a square plus b square. Again dividing this by this, we would have get tan theta is equals to b by a, or theta is equals to tan inverse b by a. Now the given formula could have been written in the form of in this way. So using the values of a and b in this, we get here a square plus b square is equals to r square. A means r cos theta we are writing, and b means r sin theta. From here we can take as r common, and we can write in the format like this, which is equals to e to the power of ax by r square into r. Now see, this is cos theta, cos bx plus c, sin theta, sin bx plus c. We can get it from class 11 that cos of a plus b is equals to cos a cos b minus sin a sin b. So here it is a plus sign, so this becomes cos of bx plus c minus theta. Now we know that theta is equals to tan inverse of b by a. So finally we can write it. This gets cancelled off here. E to the power of ax by r cos bx plus c minus tan inverse b by a. Here we know that r is equals to root over a square plus b square. So final answer becomes e to the power of ax by root over a square plus b square into cos bx plus c minus tan inverse b by a. So finally we are getting the answer of this is in terms of this. Suppose instead of here cos, if would have been here sine, then your answer would have been, instead of cos here would have been sine. It's a very easy to remember. So the 4 formulas which we have learned today is very helpful in your examinations. So keep on watching this and do subscribe. Whenever you get filled out, you can ask me